Now, I invite Professor Patrick Hettiaratchi for presenting his deliberation. This will be the last deliberation in this session.
Okay, I'm back again. I guess this time I'm going to talk about the research needs as an academic, the way I see that. I guess we discuss a number of topics, and I've heard lots of points of views from the people who want to develop technologies and apply technologies, and the regulators and all those people. But I think the one thing I've noticed here, and also when I was in Sri Lanka, was that sometimes we discuss and we argue in a vacuum. There is a lot of information that's missing out there. So the question is, at the front end we can say, okay, do we need that information to make our decisions? But I would say it is necessary sometimes. Without making decisions, without the proper information, will lead you to change your path as you go forward. So the critical thing here is not only to collect the right information and collect the credible information. We heard information, but are they credible? That's the question. That's out there. And are they specific to the Indian conditions? That's the other thing that you want to be careful about. I just want to give you a couple of examples. When you talk about composting, we know there are trace metals. I don't want to use the term heavy metals because trace metals covers a broad range. So the trace metals, what happens to the trace metals once they are in the environment? Do we understand how it migrates in the food chain? Do we have that information to make our decision to say, okay, the composting makes sense, and what are the implications from a public health point of view? And another one is the take emissions from incinerators. We saw numbers and things like that. Are they credible under Indian conditions? And what are the implications to the human health? We know we have problems with air pollution, and once we add more air pollution, what are the implications? How many people are we going to kill in the longer term by producing that? Do we have that information? If you don't have that information, can you make the decisions? That's the issue. So now, just to expand, take landfills. If you are looking at landfills produce gases. Do we have the numbers to generate and calculate or present that information in a credible way? You heard some numbers. 3% of the global greenhouse gas emissions come from landfills. Who knows? Because these are all theoretical numbers made under assumptions. And for example, that includes the Indian numbers as well. The way that they will generate is they will associate certain parameters and your theoretical value and calculate that. But you don't have your numbers for exact parameter values for the Indian conditions. The question is, when are you going to develop that? How do you make sure that your estimations, your assumptions are correct? So the two main parameters that you require when you want to calculate and find out the emissions from landfills, we call them KL0. Those values are very site specific. You can't use the numbers from United States when you do want to those values. You have to have your own values for India, and it's the same thing in Sri Lanka. So the issue is are you going to spend that time to generate that? Why do we need to do that? Because these are being used as decision-making tools. We say that there are emissions from landfills, large amounts. Okay, are these correct? And then the other question with using this KL0, K refers to the rate constants. That tells you how quickly the gas production occurs. L0 is an ultimate gas potential. And those values are taken an example to show that those values are required for various locations and various landfills, whether they are open dumps or central landfills. Also, you need that kind of information if you want to generate gas to energy plants in the future, CGM projects. Now, those are based on those calculations. But do you have the numbers? And how are you going to do those numbers? And that's what's going to the research community. So I'm basically addressing the academics and the research community, but I'm pretty sure the practitioners will benefit from that as well. So that's one point. The other point I want to make essentially is, you hear about technologies. How do you select? How do you know which is best? That's the biggest question you have. We use a technique in Canada. In fact, we developed that and we have applied that in various situations based on life cycle. The life cycle based approach, if you want to evaluate the human health impacts and also the GHG emissions and also the social impacts. When you talk about a project, when you talk about technology, you have to look at the big picture as well. You can't just say, okay, I'm going to produce this much energy out of this, or I'm going to do this, or get a certain amount of compost without understanding the life cycle human health impacts associated with that. So, for example, if you take composting, we have the issue, you apply the compost on land, what's going to happen to the people who use the land to grow something, and what happens over the longer term, are we going to have an impact? So there are techniques available to do that. You can do a kind of what we call a quantitative assessment. It's not qualitative, it's a quantitative assessment. Then we can compare one with the other. That's human health risk based. Take for example again the incineration. As I mentioned, that incineration produces pollution. There are methods to figure out how much impact that will have on the human health. How many people will be hospitalized over time because of that kind of things. But then once you have those in the same basis, you can compare them. You can say the composting kills, I'm just taking numbers, composting kills 5 people, incineration kills 10 people, landfills kills 2 people. So that's one basis you can do, because landfills are pretty well localized. The problems are related to groundwater contamination. If somebody drinks that water, you got a problem. You can control that as well. So what I'm talking about is the methodology that's available that can pretty well define the so-called, the impacts, human health impacts, social impacts, as well as maybe you can look at the GHG emissions. You can do that on a life cycle basis. If you're taking a landfill, for example, there are emissions going into the atmosphere from the methane and the carbon dioxide, and also if you're transporting material from point A to point B, there are emissions associated with that. You can calculate that, and then you can compare that directly with the emissions from say incineration, because there are emissions associated with that. But you do the life cycle assessment. That way, pretty well, you can come up with a kind of a tangible way, or I would say a quantitative way. You can compare apples to apples. Otherwise, we are not comparing apples to apples. That's what's happening all the time. There are good in this, there's bad in this. You are just comparing apples to oranges, because technologies are different. So the way that you can bring that together is to bring it to the same platform, and that's the method I was talking about here. But I think those are things that the academics should be looking at. Develop these kind of techniques that will help the regulators as well as the local administrators to figure out, okay, what is good for me? How do you do that? And you want to have a credible way of doing that rather than listening to this person and something happened out there. So that is very qualitative, and this is much more quantitative, something that I'm putting out. So if somebody wants to discuss that or ask questions, we can do that later on. Thank you.
Thank you very much, Professor Patrick. Now we are coming to a session for discussion, and